Okay, let's take a look at it. It says the point minus 4,3 is on the terminal side of an angle in standard position. Probably like we've done in class, I would draw a picture. It doesn't be terribly accurate, but abscissa, or the x-axis, the ordinate. Let me just call this x-axis, okay? This is y-axis. And the point minus 4,3, I'm going to say probably over here somewhere. All right, minus 4, and then 3 up. And I'm going to put a ray here, like this. If you want, you can draw the circle in. Not a great job drawing a circle, but that's my circle. The x equals minus 4. The y equals 3. And the r, let's go through that. So r squared is equal to x squared plus y squared. So r squared, by the way, r is a positive number. X squared would be 16. Y squared is 9. 16 and 9 is 25. So the r is 5. Now what do they want us to do? They want us to find the values of the 6 trigonometric functions of the angle formed. Well, this is the angle that's being formed over here. That's theta. So it's going to be sine of theta. It's going to be the cosine of theta. It's going to be the tangent of theta. Oops, that's theta, not 0. And then you got the cosecant of theta, the secant of theta, and the tangent of theta. All right, one thing at a time. If you don't know the definition, it'd be hard to answer these questions over here. But they're relatively simple. It's going to be, the ordinate, which is 3, over the radius 5. The cosine is defined as being the abscissa, which is minus 4 over 5. And the tangent is going to be the ordinate over the abscissa. And that would be, if you wrote that down, that would be 3 over minus 4. But that's an inappropriate way to write it. So minus 3/4. All right? These other guys are easy to do. The reciprocals. This is 5/3. This is minus 5/4. And this is minus 4/3. All right? That problem is done. And let's move on to the next question. The next question is, find 2 positive angles and 2 negative angles that are coterminal. So let's write it down. What are you going to get over here? Well, a coterminal, I'll just write down, let me write down theta k, where k is some integer, would be 4 pi over 3 plus 2 pi k. The understanding is k is any integer in the universe. Anyone, all right? So I want to write a little bit differently. I'm going to write 4 pi over 3 plus 6 pi over 3k. So this is, why would you do that? To make the arithmetic easier. Let's start writing some down, all right? Let's take, let's take theta 1. That means k is 1. What are you going to get? 4 pi plus 6 pi is 10 pi. Let's take theta to be, 2. What would that give me? Well, if k is 2, that would be 12. 12 plus 4 is 16. Well, I got 2 positive coterminals now. I want to look for a negative one, all right? Let's take a look at that. I'm going to say theta minus 1. Well, that's going to be 4 pi minus 6 pi over 3, of course. And you're going to get minus 2 pi over 3. I'm going to do theta minus 2. That'll be minus 12. And minus 12 plus 4 is certainly easy. It's minus 8. And again, we're talking about pi's over 3. So I found 2 positives, and I found 2 negatives. All right? Let me go on. What's the next one going to be? Find the exact area of a sector. All right, just to remind you, area of a sector is going to be 1/2 theta times r squared. Theta must be in radians. Let's write this down. So the area of this sector they're talking about, well, it's going to be 1/2. The theta is 135 degrees. I have to convert that to radian. So it's going to be pi over 180 degrees times the r. Find the exact area of the sector. Oh, look at that. The diameter is 5. So that means the radius is 5 over 2 meters. right? Half of the diameter. So let's write that down. That's going to be 5/2 meters squared. Let's do the arithmetic, at least the arithmetic that we can do. And I'm only going to do arithmetic that I really can, I would say grade school arithmetic. And that's going to be 3π/4. And then 5 squared is 25. 2 squared is 4. And I get metered squared. I'm going to keep going and see if I can do that. Well, it doesn't look too bad. It's 75 pi. And then you get 2 times 4 is 8. And 8, did I make a mistake somewhere? Pi/4. Gonna look at this thing. And 5 squared is 25 quarters. Yeah, I think I did it right. And what number you get there? 632. And this is going to be the unit of that thing is going to be meters squared. They did say use proper unit. All right, let's go to the next one. And, oh, this one's find the complement. I got to remember that now. Complement, supplement. Well, it's an acute angle, I'll be able to do it. So the first thing I write down is, I'm going to write down the complement. And the complement's going to be 90 degrees minus the angle. And you say, what's the angle? Well, the angle it's kind of crazy looking though, isn't it? It's 37 degrees, 42 minutes, 39 seconds. Well, it's a mixed number, so I need to write 90 in terms of a mixed number. And that would be 89 degrees, 59 minutes, and 60 seconds, minus, let's see, 37 degrees, 42 minutes, 39 seconds. Well, I think I can do that. 89 minus 37 is going to be 52 degrees. And 59 minus 42 is going to be 17 minutes. And 60 minus 39 is going to be 21 seconds. So that's my complement. I'm going to put a box on it. And again, we're only doing grade school arithmetic. What's the next thing going to be? The supplement. The supplement is going to be 180 degrees minus that acute angle, which is 37 degrees. Whoops. My eraser out. 42. 39. Same thing, going to borrow. So it's going to be 179, 59, and 60. Minus 37, 42, 39. Again, they're mixed numbers. Let's see, 179 minus 137 is 142 degrees. 59 minus 42 is 17. And 60 minus 39 is 21. Put a box in that and move on to the next question. All right, next question says the terminal side of theta lies on a given line. Well, that's not too bad. I put the line down for you. And the line looks like this over here. It's the x-axis. This is the y-axis. And to graph a line, I need 2 points, and it looks pretty simple. I'd say 0, 0 is one of the points. This is xy, by the way. And the other point I would pick is probably a 5 for x, and then you would get minus 4. Now let me see if I can do that. I'm going to say there, and then I get, let's see, I'm going to say somewhere about over here. All right, I'll draw my line. And what I want to do is, talk about, it says the terminal side of theta lies on this line and in a specified quadrant, and it's in the second quadrant. So the theta is here. I got to pick a point here. And what point would I pick? I probably would pick minus 5, 4. Let's write that down. Minus 5, 4. If you want to put the circle in, you can. It's not really adding much to the problem, but you could if you want to put the circle in. So I'm going to write down this, what the x is. The x is, it's in the second quadrant. This is the second quadrant. The x is minus 5. The y is 4. And now I got to put the r down. All right, let's see if I can do that. And the r squared, just to remind you, is x squared plus y squared, r squared. X squared is 25. 4 squared is 16. That's going to be 41. So the r is actually the root of 41. All right, let's write this down now. Sine of theta. That's going to be the ordinate, which is 4, over the radius, which is root 41. I'm going to write down the cosecant of theta. That's going to be root 41 over 4. I'm now going to do the cosine of theta, and that's going to be the abscissa, which is minus 5 over root 41. I'm going to write down the secant of theta. That's going to be minus root 41 over 5. I'm going to write down the tangent of theta, and the tangent of theta is going to be the ordinate over the abscissa, which is 4 over minus 5, so minus 4/5. And that means the cotangent of theta is minus 5/4. All right, that's done. Let's do the next one. This is number 6. And number 6, an Earth satellite, circular orbit, 2,600 kilometers above the Earth. And they tell me what the Earth looks like, and the Earth looks like this. And the Earth has a radius of, and it's given to me. It's in the notes, by the way, right over here. Its radius is 6,400 kilometers. So I'm going to say, this radius here is 6,400 kilometers. But the satellite is above the Earth, and how much above the Earth? It's 2,600 kilometers above the Earth, and it's rotating around the Earth. All right. So what do they tell me? They tell me that they want to know something about linear speed. So I'm going to say linear speed v is equal to r omega. All right. I don't know the linear speed, by the way. I do know the radius, though. And the radius for this over here is 6,400 plus 2,600 kilometers. What's that going to give you? Let's see, 9,000 kilometers. Now, do I know the angular velocity? And it goes on to say it does 1 revolution every 8 hours. I got troubles, though. I want to point out the troubles are. This formula is derived from S equals R theta, and the theta must be in radian. So this must be radian per time. But I got revolutions per time, so I need to get rid of the revolutions. And what's that going to be? Oh boy, it's going to be every 1 revolution is equivalent to 2 pi. And I think I can do it now. Let me write that down for you. And kind of looking at it, I don't want too much arithmetic, but I'll do some. I think revolution is pretty obvious. That disappears. And I know the unit I'm going to get in this problem is going to be kilometers per hour. So how do you know that? I'm looking at it. I'll point out what I'm looking at over here. I'm looking at kilometers per hour. I know that much. And what do I got there? I know I got a pi. Not much I can do about that. Again, we're not expected to do anything beyond grade school arithmetic. And, 2 goes in 4 times. So I get, 9,000 over 4, which would be 4,500 over 2. Let me write that down. 4,500 over 2. And that would be your answer. Again, we're not expected to go beyond grade school arithmetic. Let's go to the next question. And next question is multiple choice. Right? It says a circle has radius 2. Right? I understand that. Then what's the radian measure of an angle whose vertex is the center of the circle? Let me kind of remind you, we've done something like this before. That's a circle of radius 2, by the way. And it says, it's at its vertex, and then the center is at the, I'm going to put it at the origin, and this is the vertex, and it cuts an arc length of 1. So let's put this over here. So this is 2, this is 2, and this is 1. Not a very good picture, by the way. And the reason I say that, I'm going to make a better picture for you. We're not even at the question yet. So circle radius 2. I'm going to do this over here. So it's radius 2. That's 2. And this is 1. Now, someone says, what do you mean this is 1? The arc is 1, and the radius in this case is over 2. What's their question, though? They say, if the circle is radius 2, I got the picture of it, and what is the radian measure of the angle? Well, I think I know that. And theta, right, let's write this down. S, the arc length, is equal to r theta. What's the arc length? It's 1 unit What's the R? The R is 2 units. And what's the theta? Gee, I don't know, but now I do. What's the theta going to be? 1 over 2. Let me see if that's there. And it is. It's choice D. Let's go to choice number 10. And they want to know for what values, let's see if they could, for what values of theta is the cosecant not defined? Well, I'm going to just remind you that it's probably a good idea to know the sine function. And the sine function looks like this over here. And yeah, it extends forever, by the way. And if you did the cosecant function, it's just reciprocal. It looks like this over here. And I think we've been doing this for some time, by the way. So I'm kind of looking at it. I'm wondering, where's it undefined? At this asymptotic behavior is undefined. So I'm kind of looking at it, and I'm going to say it looks like theta, right? Like if I looked at it, this would be, 0. This would be pi over 2. This would be pi, so forth and so on. So I'm going to say it looks like multiples. I'm sorry, I made a mistake there. I just noticed it. It's pi. So I'm going to say it looks like any multiple of pi. So k times pi, with the understanding that k is any integer in the universe, right? Whether it's 0, 1, 2, whatever. I'm sorry, I made another mistake. This is 2 pi. Okay, let's see if I did this. For what values of theta is f of theta equals cosecant of theta not defined? The cosecant's a reciprocal of sine. So I'm pretty comfortable that it's going to be any integer multiple of pi. So I'll put a box in this over here. Again, with the understanding that k is any integer. You could also write down integer multiples of pi if you want. Well, let's do number 9. And which says, if theta equals 7 pi over 3, well, let's put this down. Let's just, practice some things that we know about and how to convert that to degree measure. You don't have to, by the way. It's certainly a multiple of pi over 3. So it's going to be 180 degrees over pi. Pi's would cancel. 3 goes into 180 degrees, 60 degrees times. So it's really 7 times 60 degrees. So someone says, how are you going to do that? The way I've always done it, I visualize it, all right? So, if I just did this, that would be 6 times 60 degrees, because 6 times 60 degrees is 360 degrees. But I got to go more. And I'm going to get this over here. So the reference angle of this one is 60 degrees. And I certainly know about that, all right? So I'm going to say I'm in the first quadrant. I got a reference triangle, relatively simple, 60 degrees, and that's going to be root 3. This is going to be 1, and that will be 2. Now again, theta is 7 pi over 3. All right? So what do they want to do? The 6 trigonometric functions. Well, sine of theta, kind of looking at it, it's root 3 over 2. That means the cosecant of theta is going to be 2 over root 3. The cosine of theta is going to be 1 over 2. That means the secant of theta is 2. The tangent of theta is going to be root 3 over 1, which is root 3. And the cotangent of theta is going to be that guy's reciprocal, so 1 over root 3. All right, that's done. Let's see if there's another question, and there is. All right, this is probably the question where a lot of people get confused about what we're asking you to do, and what we're asking you to do is, use the provided graph. And it's figure 1. I'm seeing it. And they want me to find the period, amplitude, and 5 characteristic points of f. Let's go through this. And I got a picture to help me with it. So I'm going to write down the beginning of it. And you've been doing this in class for a while. That's where pi x minus pi over 2 is equal to 0. That means pi x. Let's take a look at that. Pi over 2. And I'm going to say x equals 1/2 now. That's pretty simple. Let's do the ending of it. And that's when pi x minus pi over 2 is equal to 2 pi. That means pi x. Well, let's see, it's like 4 pi, so it'll be 5 pi over 2. Okay? And what's x going to be? 5 over 2. If you want to put the table down, you can. Hoping you get a little better at this. But we got x, and then we got f of x over here. And I got 5 positions over here, so like 1/2. And then you got places in between, right? And then you got 5 halves in the end. I'm hoping it's a very simple counting problem for you. So 5 halves and 1/2 is 6 halves, and half of that is 3 halves. 3 halves and 1/2 is 4 halves, half of that is 2 halves. Well, pretty simple counting problem, isn't it? Counting by halves. 1/2, 2 halves, 3 halves, 4 halves, and then 5 halves. Working out pretty nicely. Let's put our values down now. And again, if you're quick at it, please just be quick at it. This is going to be 2 times the sine of 0 minus 3. This will be 2 times the sine of pi over 2 minus 3. This will be 2 times the sine of pi minus 3. This will be 2 times the sine of 3 pi over 2 minus 3. And this will be 2 times the sine of 2 pi minus 3. Well, the first one, sine of 0 is 0. 2 times 0 is 0. 0 minus 3 is minus 3. What's the next one going to be? Well, sine of pi over 2 is 1, and 2 times 1 is 2. 2 minus 3 is minus 1. Relatively simple, isn't it? Sine of pi is 0. 2 times 0 is 0. 0 minus 3 is minus 3. The sine of 3 pi over 2 is minus 1, and 2 times minus 1 is minus 2, and minus 2 minus 3 is minus 5. And last but not least, the sine of 2 pi is 0, and 2 times 0 is 0, you get minus 3. All right? So I think I'm ready to write down the period. And the period is the distance between this and this. And that's 4 halves, which is 2. I got the period done. They also asked about the amplitude. The amplitude is the distance between the tops and the bottom of it, half of that. And it looks like the distance over there is 4 units, because it looks like, minus 1 to minus 5 is 4 unit difference there. And half of that would be 2. All right, got this over here. Now let's plot our 5 points, and we'll be careful about it. And the first point I want to do is, I notice I want to concentrate on something over here. And so what are you concentrating on? I'm concentrating on the minus 3. And I want to look at those points first. So I'll put the points down for you. I see one there, I see one there, and I see one over here. And we'll talk about those points in a moment. But there's 3 points with the minus 3. There's also a minus 5 point. Minus 5, minus 5. All right? There's also a minus 1. And I'm seeing those like here, here, and here. And let's see if we can start labeling those. All right? And the first one I want to go for is this one over here, the 1/2 minus 3. Well, looking at it, I'm kind of, it looks pretty simple. It's 1/2 minus 3. All right, let's look at the next one. And that looks like 3 halves, which is 1.5 minus 3. And this one over here, it looks like 5 halves, which is 2.5 minus 3. All right? But if you take out a ruler, I want to point out what I mean by that, and you kind of measured it. I hope you realize it is 2.5. This is 1.5. And this would be exactly 1/2. All right? Let me get rid of my ruler. There's no need to use a ruler, by the way. Let me do the other points. I got 3 labeled. And let's do this one over here, the minus, where it's minus 1. Let's take a look at that. And it looks like, 2 over 2 is just 1. So it's 1 minus 1. Again, if you took your ruler out and measured that, you would see it to be 1. I get rid of my ruler. You don't need a ruler, though. And the next one is going to be this guy over here. And I want to see if that's in the list. It's not in the list, is it? All right, so I gotta say, how many points I got listed? Oh, I'll put this one down. I'll put the minus 5 point down. And I think this one's listed. What's it going to be? It's over here. And minus 4 over 2 is minus 2, comma, minus 5. All right? Let me just show you with the ruler again. I said that's minus 2, right? Sorry about that. Got to get this thing perpendicular, don't I? And I hope you realize you're looking at that. That certainly looks right in the money, doesn't it? And let's see, minus 5. And again, I'm really kind of nitpicking here, but perfectly drawn as far as I'm concerned. Now, did we get 5 points? We did. Right, so it says, could you get the other ones? And you could. What do? I mean, you just basically count it. It's going up by half. Now, someone says, do I need to get those? No, but maybe you did get those. What'd you get? Well, 5 halves up a half is going to be 6 halves, which is 3. What's the ordinate -1? I'll label that point for you in case you did that one. This one over here, you go back from a half, that would be 0. You get -5. And if you want to get this point over here, you move back a half. What would it be? -1/2. I'm sorry, I missed a point. -1/2, and that would be -3. And this one over here is going to be -1, and then you would get -1 over there. All right, and we're done. I think that's the end of the exam. I hope you didn't find it too difficult. You did well on it. If not, though, you want to start considering what's going on with why you're not doing well on these exams. Thank you for paying attention.